This time we're going to talk about the pyruvate dehydrogenase complex and the Krebs cycle. So the pyruvate dehydrogenase complex, don't forget, was your ticket into the mitochondria. So let's draw that a little bit better. So we started out with a molecule of glucose, our traditional typical carb that we start with. We went through glycolysis and we got to pyruvate. This time we have enough oxygen, so we have sufficient oxygen to get into the mitochondria. So what we're going to do now is we're going to go to acetyl-CoA. We're going to cross into the mitochondria from the cytoplasm. We're going to make a molecule of acetyl-CoA so that we can do the Krebs cycle, go to electron transport, and get ATP. So our first step, our first thing we've got to do after we've done glycolysis, before we can do the Krebs cycle, is the pyruvate dehydrogenase complex. So this is our ticket into the mitochondria. It's our ticket into the Krebs cycle, and it's our link between glycolysis and the Krebs cycle. It's not part of either. It's the link between them. So let's talk about what we do there, and we'll talk about the easy way to remember it. So we started with that molecule of pyruvate, 3-carbon molecule, as you remember. Or if you don't remember, remember that we started out with a 6-carbon glucose. We cut it in half. Half of 6 is 3. So you kind of do remember, even if you don't know you remember. We're going to take that pyruvate to acetyl-CoA, a 2-carbon molecule. And we're going to go through some steps to do that. When you see complex, that means multiple enzymes. Multiple enzymes mean multiple steps. So the first step that we're going to do is we're going to decarboxylate the pyruvate. If I decarboxylate, that means I'm taking carbon dioxide off. We kind of don't care about carbon dioxide, but we kind of do. If we see carbon dioxide coming off, we know we went down a carbon. There's 3 going to 2. If we see it going on, we went up a carbon. So our carbons come on or off often in the form of carbon dioxide. So even though it's kind of a waste product and something we don't particularly pay an awful lot of attention to, we kind of need to, for that reason, to keep track of what's going on. When I decarboxylate, I need a B vitamin. Really common thing to get asked. So I would know that I need thiamine, pyrophosphate. So I decarboxylate using thiamine pyrophosphate. Now I go through that little oxidation reduction series on the 2-carbon intermediate that I now have. To kick it off, I need a molecule of lipoic acid going in. I oxidize my 2-carbon intermediate while I reduce FAD to FADH2. Then I don't leave my FADH2 alone. Oxidize it back to FAD while I reduce NAD to NADH. So I get a molecule of NADH as a product. Kind of cool, because when I get NADH as a product, that means that I have an ATP equivalent that I can go and turn into ATP. Then I put a CoA on. I've got myself at that point a molecule of acetyl-CoA. So we have some mnemonics. I don't see why not to teach them, not to give them to you, so I do. Also, I think a good reason to give them to you is because there's usually issues with them. And of course, the issues are where everybody asks you the questions. So the mnemonic for this is these 5 coenzymes love nutrition. And I'm going to pause for 1 second. Sorry, we had a parrot gone rogue. So these 5 coenzymes love nutrition. Traditionally, typically, that mnemonic's used for what goes in. We can use it for in and out. We're stretching it a little bit on the out, but that's okay. So what goes into the pyruvate dehydrogenase complex? Well, let's go through the story. These 5 coenzymes love nutrition. So what do we do first? What we do first is we decarboxylate. We need thiamine pyrophosphate going in to decarboxylate while carbon dioxide comes out. Then we go through that oxidation reduction series. Lipoic acid goes in, FAD goes in. However, FADH2 does not come out. It's kind of an in-between. Intermediate is the proper word for that, because we oxidized our 2-carbon intermediate while we reduced FAD to FADH2. However, we don't just leave the FADH2 alone, we oxidize it back to FAD. So FAD actually comes out too. While we reduce NAD in to NADH coming out. Then we put that CoA on there, our other N, and we've got our acetyl-CoA. However, this is what catches everybody. Don't forget another big reactant and a big product, and this is the losing the forest for the trees thing. Pyruvate's a reactant. It has to go in, or we don't have a pyruvate dehydrogenase complex. Acetyl-CoA comes out, and it's not infrequent for you guys to forget these. So watch out with those too. So now I've got myself a molecule of acetyl-CoA. I'm ready to go. I'm ready to kick off my Krebs cycle now. So I'm going to stop this share because I've got to go to a different screen. I don't think it's going to let me go.